na karibu kwenye channel ya Dr. Mlelwa Lectures. Tunafundisha masomo ya sayansi, physics, chemistry, mathematics pamoja na biology kwa syllabus ya Tanzania na kwa O-level pamoja na advanced level. Dr. Mlelwa Lectures, for your better NECTA EXAMS performance. Subscribe, share and like this video. Welcome back, friends. In the last session we was discussing with the secretion of the gastric juice, and in this session we are continuing with the pancreatic juice and bile. So let us continue. And as we said that in the intestinal phase we had the CCK and the secretin produced in the cells of the duodenum, but they go to act on the stomach. As we said that the secretin go to inhibit the secretion of the gastric juice, and the CCK prevent the stomach emptying. Also, we had some of the reflex from the brain which passes through the vagus nerve, which prevent the stomach emptying and the secretion of the gastric juice. Now let's continue. Secretin and the CCK are produced in the duodenum when a stomach chyme enters it from the stomach, as we said in the above explanations. Now secretin is produced in response to the acid, whereas partially digested fats and proteins stimulate CCK production. You see, secretin is stimulated in response to the acid, while the partially digested fats and proteins stimulate CCK production. So until here unaweza kuona tu kwamba secretin itakuwa na kazi gani na CCK itakuwa na kazi gani. Probably secretin will have the function of producing something which will neutralize the acid, while CCK will have the function of stimulating the production of the enzymes which will complete the digestion of fat and the proteins, hata kabla hujasoma mbele. So both hormones are important regulators of production of pancreatic juice and bile juice. Starting with the secretin is in effect an anti-acid hormone. As we said that it is produced in response to the acid, so it is an anti-acid. Yenyewe inapambana na acid. So it stimulates the production of hydrocarbonate ions in the pancreas and in the liver, making the pancreatic juice and the bile more alkaline as a result. So unaona hapo yenyewe ina stimulate the production of the hydrocarbonate ions in the liver and in the pancreas. So the bile and the pancreatic juice, they become more basic, na mwisho wa siku zina neutralize ile acidic chyme kutengeneza pH ya 7 ili enzymes ziweze kufanya kazi effectively. As we know that the function of enzymes they affected by the pH, as we discussed the more details, as we was discussed the more detail in the biochemistry. Kama haukwepo basi waweza kuangalia tu vipindi vyangu vya biochemistry kwenye mambo ya factors affecting the enzyme controlled reaction, na unaweza kuona hivyo vipindi ambavyo vinaeleza hiyo enzyme. Lakini pia ni kwamba this help to neutralize the acid from the stomach. Now let's move to CCK. CCK stimulates the synthesis of digestive enzymes by the pancreas and the contraction of the gallbladder to release the bile onto the duodenum. The bile is made in the liver but stored in the concentrated in the gallbladder. It has a pH of 7.6 to 8.6. I will discuss more of bile in the topic of excretion, when we will be discussing about the major functions of the liver. And of course it is not in syllabus to discuss about the bile and its formation. For your level, maybe for your university level, you may discuss many things about it, bilirubin and how the bile salts they are formed. But for your level, it's not in the syllabus to discuss about the bile formation. We are just discussing these things so as to make your thinking deeper, or to make you wise. Having the wider understanding will simplify you to answer questions and to perform well in your exams. That's why in most of my exams I performed well. It was not only because my teachers they taught me well. Most of these things I prepared myself, and I used to study books myself. So what I came to realize later is that it is because I fighted, and not only fighting, but it's because I had the wide range of knowledge. That's why I was able to tackle many of the questions. Now let's continue. CCK stimulates the release of the digestive enzymes by the pancreas, as we know within pancreatic juice, as we discussed in the last sessions. We have different enzymes present in the pancreatic juice. We have protease, we have lipase, pancreatic lipase, we have carbohydrates, which digest carbohydrate. And as we know that most of digestion takes place in the duodenum, as there are three secretions which meet together, which is bile, intestinal juice, and pancreatic juice. All those, they are performing the work of digestion. So that's all about the pancreatic juice and bile. Their secretion is stimulated by the CCK and the secretin. And as we said that the secretion of secretin is because of the presence of the acidic food, and production of CCK is because of the partially digested fats and proteins. The secretion of bile in pancreatic juice is also stimulated by the nervous reflexes. During the nervous and the gastric phase of the gastric digestion, the vagus nerve also stimulates the liver to secrete bile and the pancreas to secrete enzymes. So, as you see, in the control of the digestive system, hapo vitu vinakuwa vinafanya kazi kwa pamoja, nervous pamoja na hormonal. Now from there, let's see a little about the fate of absorbed food materials. Most of teachers, they don't teach this part, and you may think that it's out of syllabus, but it is very important to know it, because sometimes if you don't know the fate of food, it will be very, very difficult even to answer some of the questions which you will be asked by your teachers, or even to understand some of the concept. Kwa tunavyoenda kusoma, tena kusoma respiration, tena kusoma excretion na vitu vingi. Sasa uko mbele, I don't want to confuse my student kwamba hichi kilikuwaje, kimetokea wapi. So in order to be in the same line, I teach this part, so as uko mbele when tutakavyokuwa ongea vitu vingine, it will be very easy for you to understand. Now first is monosaccharide and amino acids. They are both absorbed into the blood vessel in the villi and pass to the liver in the hepatic portal vein. Most of the glucose is stored here or in the muscles as glycogen and fats, though some live in the hepatic vein. Some live here, the words are repeated. Some live in the hepatic vein to be distributed along the body, where it is needed for oxidation during respiration or for use in other function. As we said that the function of the liver, it stores excess, or it releases what was stored if the concentration is small. Now most of time sisi wanadamu hatujui tu, lakini huwa tunakula chakula kingi kuliko kinachohitajika, na ndio maana huwa tunaenda chooni. Kwenda chooni ni kumaanisha kwamba that is undigested. Kwa nini undigested? Because it is excess, it is not needed by the body. Sio mara zote tunaenda chooni tunakunya tu cellulose which are not digested. No. Sometimes hata kama umekula ugali mwingi, ukienda chooni maana unachokunya, that part of that feces is real ugali. Kama tungeenda kufanyia food test, is ugali, and it is undigested. Why is it undigested? Hata kama inatoka na kala nyingine, ile ni kala nyingine kwa sababu tu impita kwenye intestine, but it is real undigested. If we go to test it in the lab, we may find starch there, real starch, not a reducing or non-reducing sugar. However, we may find reducing sugar because in the mixture of that undigested food, we may have few molecules of glucose which were there during the process of digestion. But what I can say is that we are always consuming excess. So most of times blood inapopita kwenye liver lazima istore excess na kuacha baadhi kwenda kutumika kwenye other parts of the body. Now between meals, if the body requires more energy, glycogen in the liver can be reconverted to glucose, transported by the blood to those tissues in need. Amino acids are used for synthesis of protein, which have different functions in the body, as we discussed in biochemistry. They are used particularly for growth and repair, being some of the main constituents of the protoplasm. Enzymes and some hormones are proteins. Sulfur amino acids cannot be stored and they are deaminated in the liver. So sulfur amino acids, they cannot be stored in the body na zinakuwa deaminated. So kama zikiwa absorbed from food, kama zinahitajika wakati huo, they are used. But if they are not required by the body, they can't be stored. And not only sulfur amino acid, generally it's all amino acids, they are not stored by the body. Exactly, we'll go to discuss this in more detail in excretion. But generally, amino acids, they are not stored in the body. They can either be converted into carbohydrates and being stored, or into fats and being stored, but not amino acids. One among the reasons why amino acids, they are not stored, because most of the amino acids, they are amphoteric and they have the reactive group, can be negative charged or positive charged. Being charged and having the reactive group means they are very reactive, and if they are left to accumulate in the body, they can alter the pH of the body fluid, and if the pH of the body fluid is altered, the enzymes cannot work in the proper fashion, hence the cell can die. Kwa unaweza kuona hiyo reason ya kwa nini hatustore amino acid. That is because the amino acid, most of the amino acid, they are charged, and if we accumulate them in the body, they can change the pH. They can change the pH of the body fluids, and changing the pH of the body fluids can lead to enzyme denaturation or enzyme inactivity, which will lead to cell death. And if the cell will die, means the whole body can die. So that's why the body, in order to prevent all of those effects, it tends to excrete, either to break down and excrete excess amino acids, or to convert them into lipids and carbohydrates. So we are saying that their amino group are removed and converted to urea, which is taken in the blood to the kidney and excreted in the urine. The remainder of amino acid molecule is converted to glycogen and stored. We shall discuss this later in detail in the topics of respiration and excretion. Absorbed fats bypass the liver by entering the lymphatic system and being released into the veins near the heart. Fats represent the major energy store of the body. Normally, however, glucose is an inadequate supply. Glucose is inadequate supply, and the fats are not required for the energy production. In this case, they are stored in adipose tissue, because the skin around the heart and the kidney, they are stored in adipose tissue below the skin, around the heart and skin and kidney, and in the mesenteries. Some fat is incorporated into cell membrane as phospholipid. Kwa unaona hapo fat kazaki, kuna cell membrane as phospholipid, adipose tissue, energy store, energy supply. Energy store maana kina store energy, lakini pia inaweza ka supply energy during respiration, as we shall discuss later in the topic of respiration. Let I end up here, and in the next session we'll be discussing about the common disorders of digestive system. Thank you everybody, and let I wish you nice studies. If you need these notes, just contact me with the contacts in the description below. Thank you. Ninaamini, asante kwa kuangalia channel ya Dr. Mlelwa. Ninaamini umeelewa kipindi, na kama hujaelewa chochote waweza kucomment hapo chini. Click link ya kwenye description kujoin Telegram group kwa ajili ya discussion. Usisahau kusubscribe, kushare video kwa marafiki, pamoja na kulike video hii.